Hello! Your journey as a successful engineer and an expert in systems modeling continues. Now the company is asking you to adapt the autonomous car for driving in various weather conditions, including a rainstorm. Therefore, your task now is to develop a weather simulation system. Your first assignment is to model a rainstorm system. Unlike most of the systems we have modeled so far, a rainstorm is a natural system, not an artificial one. What's the difference, you ask? The top-level diagram of the model SD of a natural system shares three components with an artificial system: main function, main process, enablers, and system environment. But the system purpose and problem creation are usually not relevant for a natural system. A natural system was not designed by humans, and therefore in such systems we refer to the outcome rather than the purpose of the system. For a similar reason, problem creation is not relevant to the SD of a natural system. So let's start modeling a rainstorm system. To do that, we are going to watch a couple of short videos made by NASA, the US National Aeronautics and Space Administration. NASA does not only explore outer space, but also the Earth. Monitoring the weather is a major NASA activity, and an important part of it is monitoring the formation of various kinds of rain systems. A tropical rain system, for example, begins in the ocean, as we can see in the video. Such a rain system, a hurricane, can develop into a dangerous storm that causes floods and other damages. So what is the outcome of our modeled system? This depends on our point of view and what we're interested in. Let's start modeling by depicting the main process of the system, rainstorm forming. What is the beneficiary group of the system? In our case, the passengers of the autonomous car, although it is doubtful that the rain is causing them any pleasure. This will happen later when the car we are designing will get through the storm and the passengers will remain dry. So, as we see, the outcome of a natural system for the beneficiary group can be positive, a benefit, or negative, detrimental or damaging. A human-made system, the car in our case, will be designed to minimize or eliminate that damage. But right now our focus is on the natural system. What attribute of the beneficiary group is transformed as a result of the main process? Since we're interested first and foremost in safety, we can say that the safety level of the passenger decreases as a result of the rainstorm forming. This is indeed a detriment. We will validate this by reading the OPL sentence. Rainstorm forming changes safety level of passenger group from high to low.
Natural system outcome. A key effect that a natural system has on its effectees, which may be beneficial or detrimental.
Thanks, Hopcat. Now let's turn to the system's main function. What is the main transformee of the system? In our case, we are focusing on the car's surrounding atmosphere, so we can say it changes from dry to rainy. What about the main process enablers? Natural systems in which people are not involved do not have agents. Indeed, no person is involved in forming the storm. And what about instruments? Well, a tropical rainstorm forms above an ocean with warm water, so we will add warm ocean water as an instrument of the main process. The OPL sentence describes the main process enabler. Rainstorm forming requires warm ocean water. Now let's turn to the system's environment. What is the meaning of environment for a natural system? In a technological system, we distinguish between systemic things over which developers and operators have control and environmental things which affect the system but over which we have no control. How will we distinguish between systemic and environmental things in a natural system? In our case, we want to understand how a rain system forms. Therefore, anything outside of the storm, but which still affects it, will be included in the system environment. A tropical rainstorm depends on the existence of an ocean and the Earth's atmosphere. We will therefore add the ocean and the atmosphere as environmental objects and connect the atmosphere as an instrument to the main process. The storm requires the atmosphere air. Of course, warm ocean water is part of ocean. We will express this using an aggregation participation link. A systemic thing can be part of an environmental thing, as is the case here. Good! We modeled the SD of a rain-forming system. Next time, we will model the sub-processes of the main process. See you soon!